So we're just going to spend a bit of time in this one talking about the water cycle. So how water moves through the earth. And, this is fairly basic stuff you've probably gone over in grade school. You have evaporation over oceans as well as, over large bodies of water like lakes and a limited amount over rivers. But you also have this effect known as transpiration, where leaves of plants they lose water through openings called stomata, and that gets picked up by the atmosphere and turned into water vapor. And they do this because chains of water molecules are actually used in plants to transport water as well as nutrients throughout the plant. So the net effect of this, adding water to the atmosphere, is often called evapotranspiration, to take into account water from, open bodies of water as well as water transpiring from plants. So eventually this water vapor will move through the atmosphere, and if the air mass it's in gets too cold and becomes saturated with water vapor, it will condense, forming clouds. And we'll talk more about this in the next workshop. And eventually, through these water droplets nucleate around, different dust particles in the atmosphere. And if they become heavy enough, they can fall as rain or snow, or quite often they form ice crystals as snow, fall through the atmosphere, and then melt sometime before hitting the ground. And in fact, most precipitation in the northern hemisphere starts off as snow, and then, in the spring or the fall, and sometimes even during the summer, it turns into rain on the way down. So this precipitation will hit the land, it'll run off, forming streams and rivers, and we'll talk about that in the next recording. And the cycle will continue over again. So that said, it's important to note that instead of going into the river system, some of this water that hits the land, it'll infiltrate into the soil and perhaps even deeper into deeper layers of sediment, or perhaps even bedrock, forming groundwater and aquifers. And once the water's under here, it can actually move around, usually quite slowly, but in some circumstances quickly. And it can either stay down there, or it might, feed rivers and lakes. There's often an exchange of groundwater into and out of rivers and lakes, and, or perhaps somebody will dig a well and extract that groundwater. So where does the Earth's water reside? Well, most of it, almost 97%, is in the oceans. We can't drink it. So only about 2.5% of Earth's surface water is fresh water. And of that, most of it is locked up in glaciers and ice caps, almost 70%, which is, for the most part, fairly inaccessible to humans. I don't see too many people going to Antarctica to go get it, go harvest water. So what humans use is the other two sections on this chart here. Groundwater, which is about 30%, which in many areas we are quite reliant on. I believe the island of PEI gets nearly all of their water from groundwater. And then in some lucky places, we can use surface water. So say in the Great Lakes region, where I'm from, we're very lucky that we have that super abundant ancient source of fresh surface water that's fairly easy to access. So when we're looking at the surface water here, a lot of it is locked up in permafrost, which again is very difficult to use. Of course, we're losing a lot of that permafrost. Another 20% of that, 1% of that, 2% is locked up in lakes. So a very small fraction of our water. And then, at any given time, a very small amount of rivers, wetlands, some in soils, and so on and so forth. So that's a bit about the water cycle and how water moves through the earth. And in the next section, we'll talk a bit about rivers.